Good morning, beta. Inform in the group class started, please. I've shared the link also. Okay, shall we start, beta? Bhavya? Now look here. Last class we were discussing about refraction, and in that part we have discussed that refraction and reflection both are surface phenomena. Okay. Then we learned that when a light ray is entering from one medium to another medium, some part of the light rays are getting reflected. Okay, and some part of the light rays are exactly doing what, beta? Some part of the light ray will go from one medium to another, but the moment they are going from one medium to another medium, they are experiencing refraction. Understood? Means the light will bend. The light will bend how? The light will bend from one medium to another. And the normal, what is called as normal? The line that is drawn perpendicular to the surface, the light ray will either go towards the normal or it will go away from the normal. So that is something we have learned. Good morning, Divya. Good morning, Anu. Good morning, Bacha. Everyone, good morning. Shall we start the class? I'm just doing the revisions what we have studied. Okay. So we have learned this part. We have understood that the light rays will be either what you call go reflection or it will go refraction. Understood this part. And we have learned another important point that when the light will be undergoing reflection, that time the light speed will be changed. Understood? Either the speed will increase or the speed will decrease. And everything was dependent on optical density. And then we came to know that optical density is not same as normal density, because normal density is mass by volume. But here optical density has to do something with the particles that is making a glass. Down. That is making a glass. Good morning, Darshan. That is making a glass. So optical density, little bit means it will stop. Okay, and optical density has to do nothing with the 1 minute. I'll just. Good morning, Kritika. Now listen, beta. Optical density has to do nothing with the mass density, volume. Okay, it has to do with the particles. So when we are talking about particles, the particles will allow the light to enter inside the medium. Understood? So we have to understand that okay, the particles will make the object like either transparent, translucent, and opaque. Understood? So opaque means like this wall. So wall will not allow light to enter inside, na? So that means refraction is not possible. Then we came to know that okay, optical density is there. But with optical density, the object has to be either transparent. Nitya, good morning, beta. The object has to be either transparent or it has to be translucent. So these are the two different content. Understood? So we have also understood that okay, if any water is there, and in water I will add some solutions. Okay, I'll add some what you call solutes and make a solution. Like what is solute, solvent, and solution? Solute is something what you are adding in the solvent in a lesser amount, and solvent will be in a greater proportion. Okay, so solvent will be little bit more, solute will be less. Like when we are making sugar syrup, correct na? Or we are making lemonade, in that particular moment what we are seeing is when we are adding, listen very carefully children, when we are adding a solute in a solvent, colloidal solutions are made, correct na? So these solutions will also bend light. These solutions will also bend light because the particles, the solute, what is inside water, it will occupy the spaces between the water molecules. And then what will happen? It will change the medium content. Understood? So what will happen? The velocity of the light entering from one medium to another medium in that solution also will change everything. I hope you might have understood better. Understood, na, Bhavya? So this is exactly the most important thing we have learned. What we have learned about bending, we have learned about optical density. Optical density is same as normal density? No. Optical density is due to what, beta? Particles. Optical density is due to particles. And the particles are the whole proprietor. They are only allowing the light to go inside. Understood? So just I have given one example also. When Just one example I have given, that when in a room full of people will be there and you are coming from outside, till you are outside you are running like anything and then you are coming out inside, but that time nothing exactly has done, got it? But once the moment you are entering inside, lots of people are inside the room, that means what, your speed will be increased or decreased? Decrease now, because these people will not allow you to enter inside. You are also a particle here, also means you are also the rays which is exactly entering. Their particle were less, here particles are more, so definitely your speed will decrease. And then we created those children who are joining, can you say me good morning please? Please give your attendance, because every day manager is taking attendance. She is joining online and she is checking your attendance. So everyone must have to say one time good morning to me. Okay? Good morning, beta. So once you are joining the class, please kindly give me attendance. Yes. Good morning, Joseph. Jotam. Yes. So those who are coming online, definitely you have to say one time good morning. You have to write your name if other names are there. That's mandatory to be written. Okay. Good morning, beta. Good morning, everyone. So we understood a very basic property of what you call refraction. Understood. Now, another important point when we were discussing, we discussed that the movement, right, is exactly in refraction. Another important point, what is happening is कि when the movement down you go, okay, beta, little bit you have to bend down and go. No, not from that side. Okay. Because camera backside little bit means it will close. So I hope you might have understood better. So now here you need to understand it very nicely. Like, okay, fine, from the surface only bending will be there. Understood? Because the speed is changing. What is changing is speed is changing. So we learned many important points there. Okay, beta. Now we are going to continue and we are going to understand the rarer and denser medium, because previous we have finished all this: optically denser, optically rarer. These part not, sorry, this part we have not finished. Causes of refraction we have not finished. Angle between refracted ray and normal. So that part, those children who were not there. Yes, beta, that's a very good question. Can you say me your name, beta? This is a very good question you have asked. Zara asked a very important question. जब मीडियम बदलेगा तो रिफ्रैक्शन भी बदलेगा. Yes, beta. Actually, this is one of a very important thing. Many times now, I'll explain this one. About lens also, beta, I will explain. Because lens are nothing but glass, na? Spherical glasses are there. So exactly when we are making lens also, na? So when we are taking lens in air and then we are checking the object placement and the image traced on a screen, that is different. But the moment you are keeping the lens inside water or kerosene or any other medium, then its refraction also will change. That's a very important thing. Good, Peter. God bless you. So that's a very important thing. Are you understanding? So change in medium will change the refraction. I hope you might have understood this one, Nabita. So once the medium will change, the things will change. I hope you might have got this point. Now we will go for the next one, the angle between the refracted ray and the normal. So 100% we have drawn that one, Vishwa. Good morning, Vishwa. Good morning, Beta. So 100% we have exactly discussed about refraction. We have seen how it is bending is done. In the previous part, in the previous class, we have discussed everything. Okay. Then one question I'm going to ask from everyone. Are the children ready to answer my question? My one question is, if a light is entering from air to glass and coming out to air again, will angle of incidence be equal to angle of emergence? Will angle of incidence be equal to angle of emergence? Very good, Vishwa. Beta? Yes, the answer is absolutely correct. Absolutely correct, beta. The answer is absolutely correct. Yes, angle of incidence will be equal to angle of emergence. Angle of incidence is equal to angle of emergence. And how it is done, we also know that, na beta, that one inside it will bend, again it will come out. Understood? So first, rarer to denser medium, the light will bend towards the normal. Denser to rarer medium, it will go away from the normal. Absolutely correct, beta. It will be beta. It will be. But change in medium, many things are there, beta. Many things are there. Atmosphere is also one of the major factor there. Air density, air composition of particles are also one of a major role key player there. Okay. Now look here, beta. The angle between the refracted ray and the normal ray is called angle of refraction. We have already done this part. Okay. In the refraction of light, the angle of refraction is usually not equal to angle of incidence. And this part also, angle of incidence is equal to angle of emergent. Correct only, ma'am. And beta, we have learned one more thing. If you recall that part, we have learned something. In that section, I have explained another important point. So if you check this part, I have discussed this section better. In that, I have discussed that when the light is entering from rarer medium to denser medium, then angle of incidence will be greater than angle of refraction. Angle of incidence greater than angle of refraction. Why beta? Because it is exactly, it is the light rays coming like this. It is supposed to, sorry, it is supposed to go like this, but it is bending like this. Understood? So this angle is more and this angle is less. Angle between normal and refracted ray, this part is less and this part is more. When we are going from rarer medium to denser medium. Understood? When we are going from rarer medium to denser medium. I hope children you might have understood this part. Now we will be going, and you know what, when it is coming out from rarer denser medium to rarer medium, it will bend away from the medium. Uh, in this case, we can say emergent ray is equal to refracted ray. Emergent ray will be equal to refracted ray in which case, beta? When both the mediums will be same, ma'am is waiting. When both the mediums will be same, that time you can say like this. Okay. When both the mediums are same, that time only we can say. Okay. The composition is little bit similar, and that time, sorry, little bit variated. But yes, they are providing the same speed of the light ray. That time only we can talk about it. Okay. Now listen, beta, causes of refraction. There may be many causes of refraction, understood. But what in all are the causes of refraction? We are going to talk about it. So refraction of light is due to change in speed. Already we know refraction of light is due to what, beta? Change in speed. And definitely change in speed exactly started happening from the surface itself. Change in speed started happening from the surface itself. Okay. So it is due to the change in the speed of the light on going from one medium to another medium. Understood? So refraction, change in speed. So how we are going to remember that, beta? We are going to remember by shortcut words. Little bit important words only we are going to keep in our mind. First is change in speed. What word is there, beta? Change in speed. What is there? Change in speed. Where? On going from one medium to another medium, and that is responsible for refraction. What is responsible for refraction? Change in speed. But why this change? Because of change in optical density. So who is the real culprit? Optical density. So it is the optical density of the material which is exactly changing the speed of the light rays. The optical density is changing because of the optical density change means speed also change. Air optical density is different, water optical density is different, glass optical density is different, kerosene optical density is different. So every particles present inside a specific medium which is exactly providing a specific type of allowance. Okay, come inside. Understood? So the particles that is present inside the medium is allowing the light rays. Okay, come inside. Understood? But it is the particle composition which will be responsible for the bending. I hope you might have understood. Huh? Pen don't come here. You say, ma'am, pen means writing pen. She don't have pen. Okay, so I think you might have understood this one now. So here, I hope you have got this point now, beta. So just check this one out. We understood this one now. Now listen, beta. So we understood this part. So when light goes from one medium to another medium, its speed changes, and this change in speed of light causes refraction of light. Here, refraction will be there, beta. Okay, so refraction of light is caused due to change in speed. Why? Because of change in optical density. Because of change in optical density, speed is also changing. But is it clear cut understood? No doubt in that now. Why refraction happens? Change in speed of the rays. How? Yes, but how it is happening? Because of the optical density change. Because of which change, beta? Optical. Online children, is it crystal clear to you? If it is crystal clear, put a thumbs up that yes, I have understood. Crystal clear, thumbs up. Yes, beta. Very good. Vishwa understood, beta? Now look here, greater the difference in the speed of light in the two medium, greater will be amount of refraction. Greater will be, very good beta. Greater will be amount of refraction. Absolutely. Very good, Vishwa. Bless you, beta. So here, greater will be amount of refraction. This is again another important point. So see, beta, if two medium, okay, if two mediums are there, in one medium, speed is S1. Understood. Another medium speed is S2. Got it? So here, speed in one medium, like when the light rays are entering, just understand this part, ki when the light rays are entering in water, this is light rays are entering in water, and this is light rays entering in glass. So here we came to know that speed of light in water is more than speed of light in glass. What we understood from this point, just this inequality is telling us something. Let's check what is exactly this inequality is teaching us. Can you tell me? Whose optical density is more, water or glass? Whose optical density is more, water or glass? Optical density is more for glass, and optical density is less, then only speed will be less. Na opposite, optical density do opposite work. Optical density is doing what, beta? Opposite. It is working opposite. Got it? So if optical density of glass is more, then its speed will become less. Are you understanding? Note down quickly in your note, otherwise again you will do mistake. So beta, what is optical density of glass? Optical density of glass is more, so its speed is less. This you must remember. Optical density of glass is more, so its speed is exactly beta less. So that's the most important catch here. Okay. Understood. The one which is having optical density more will have speed less. And beta, if speed is less, then what about the bending? When speed will be less, what about the bending? What answer we can say about the bending? See, when you are running, beta, when you are moving, when you are running, that time you want to apply, you want to go with the shortest distance. Come on, correct na? Huh? But when you are inside a mass, means when more public is there, that time what will you will just find the shortest way to cross the lane. Correct na? You just want the shortest way. Very good, Vishwa. Absolute. Jasmita and Vishwa, super beta. So here now, you want to just go and finish it. So when the speed is less, bending will be more. Speed is less means what, beta? Bending will be more. Speed less means more bending. Understood? So here I am writing B. So where bending will be more? In water bending will be more, or in glass bending will be more? In glass bending will be more. Where bending will be more, beta? In glass bending will be more. That's the biggest important point there. You must remember, in shortest way we are learning. So who is the main thing which is exactly changing everything? The main thing which is changing everything is optical density. Understood? So now we came to know that, okay, when the light is entering from one medium to another medium, optical density is a particle behavior, and the particles are allowing the light to enter from one medium to another medium, beta. And when the particle is allowing the light to enter from one medium to another medium, some things are happening. Understood? Speed of the light ray will change. Understood? Speed will increase or decrease. Speed will increase also, or it may decrease, but it depends upon a very important thing. In what thing it is depending on, beta? It is depending upon rarer and denser part. It is depending upon what, beta? Rarer and denser, because it is depending upon optical density. Optical density change means speed change. Is it very crystal clear to you, beta? Understanding it very nicely? Now look here. So here we learn bending will be more in glass. Understood? Because optical density is more. So refractive index, what will happen to the refractive index? That means automatically refractive index Ri of glass will be more than refractive index of water. Understood? So here refractive index of glass will be more, optical density is more, but only one thing will be less, beta. If you check it very particularly, only one thing will be less, and that is what? Speed. Understood? Only one thing will be less is speed, but other things will all go with optical density. Understood or not? So optical density high means bending more. After that, come on children, type and say it. Optical density high means bending more. After that, beta, less. And after that, refractive index high. After that, one more thing, bending is more, refractive index is high. One more thing is there, speed will be less. So we came to know about a complete package of its behavior. Got it na beta? We understood, okay, by this, everything is happening. But the whole culprit is optical density. Now we came to know our perception about light will change afterwards. So window also, you might be seeing some reflections are having and some refractions are happening. Understood or not? So when the light will be entering, yes, with a high refractive index, that's something which is exactly very, very important to know. Now the third point we are going to talk about. In the third point, please check this one, children. The speed of light in air is how much, beta? 3 into 10 to the power 8 meter per second. This is the speed of light in air. Now, one question I am asking from all of you. Can you answer me why the speed of light in air is more? Okay, can I ask you one another question? If I will go in Mars, and if I will be on Earth, and if I will be on Moon, okay, will the speed of light be same? Will the speed of light be same? Speed of light in vacuum and speed of light in medium. Means vacuum means when the light is traveling from sun towards the earth, we believe that the particles are not there. It is a vacuum reason. So the particle will not do that reflection area. Okay, very good, Ayush. So here, so we learned many factors there. So when we are talking about, okay, how much time it is taking the light to travel from sun towards earth, how much time it is taking, beta? Our answer will be, Auntie, it is exactly going to take 8 minutes. How many minutes? 8 minutes. Okay, from sun towards earth. So fast it is moving. Correct, na? Years it is crossing, but how fast it is moving? 8 minutes. Approximated is 8 minutes. It is traveling. Correct, na beta? But once it is entering inside earth, the particles that is present inside, the gases, molecules that is present inside will change. Understood? It will cause bending. It will cause what, beta? Bending. And you know that the density here 8 minutes 21 seconds. Very good, Vishwa. That's what I said, approximated. Super, Vishwa. Now look here, beta. Now we are going to understand the second important point. I asked you one question that in Mars or in Earth or in Moon, understood, the speed of light remains same or different. So all the children has given the speed of light will be different. That's a very cool answer. Understood. But why? Atmospheric pressure. Okay, atmospheric pressure. So Bhavya has given an answer, atmospheric pressure. Children, without going for internet support, can we try one time? Particles composition. Are you seriously super, beta? So Hiba, good morning, beta. Now think, beta, think nicely. You can get the answer. Every answer is with us because real physics in nature. Real physics is in nature and we can trap everything from there. Think very nicely, beta. Think nicely. Your answer is with you. Trust me. Because of gravity. Because of gravity, children. You think, beta, all the answers, particles composition is one of the very good answer Ayush has given. Okay, Ayush, is it a real name? Yes, density, vacuum. Okay, so that means what we can infer, like we can infer one thing here is ki, okay, in moon the air molecules are not so much present. It is not there. Okay, atmosphere is not there. So if atmosphere is not there, means speed will be more because it is the particles which is exactly creating optical density. It is the particle which is. Yes, Raghav, you only answer, beta. I'm going to explain Snell's law also. I'm going to explain Snell's law also. Raghav, school is very important, but sometimes understanding is also important, beta. Let's play this game, understand, and then we will go to school. I'm also going to school. Okay, Raghav, bye bye, beta. Ayush has given a very super fine question. Answer he has given that particles composition. That means what, beta? The atmospheric gases molecules will be there. Understood? The one to another means the more you will go towards near the surface of any planet, the density of the gases molecules will change. It will increase. Understood or not? So that means what, layer by layer, the light will be experiencing what, beta? The light will be experiencing refraction. Understood? So simple techniques also I am going to explain. Vacuum and air, beta, you understand, vacuum or air, there is not that much difference here now. Vacuum, when we are talking about, then particles will not be there. Here in vacuum contents, we were not talking about the disturbance of the gaseous molecules. Okay, so only now we need everything is interrelated, bacha. So you need to understand one very important thing. In medium means if vacuum is there, means gaseous molecules are, we are telling that okay, it's not there. So if it is not there, the gaseous compositions are less at that particular moment. See, many things are there, beta. Yes, I'll explain one by one. Okay, because if you will rush means you will not understand. So you understand one thing, because this is refraction chapter, you must understand. So first I'll finish one part. I'm finishing that. Okay, Earth and Mars, according to their gases composition, the particle composition, they will be having their speed of light. Understood? So if any planet do not have any atmosphere, means it will be considered as vacuum only. Understood? So that's what we can differentiate moon, then Earth, optical density will be. Now it is okay. Children, you can rejoin. Now it is okay. It is okay. Children, rejoin. It is okay. So, beta, what we were discussing, that we were discussing about this content. Okay. Now it is okay, na beta, join it. Okay. Ah. So we are going to again one more time, I'm just explaining that what they have missed. So we came to know about speed change in different planets. Okay, why? Because of the composition, atmospheric composition change, because the particles will be exactly not the same. Have you understood that point, beta? Second important point we were discussing about, where were we were discussing about this one. That means finally we came to know that okay, the speed of light in air is different, the speed of light in different mediums are different, and we came to fall into a conclusion because the gaseous molecules, the water molecules and the glass molecules will be exactly changing the speed. So where is the speed very less? In glass. Means in compared to, I'm just comparing three things here. I'm just comparing three things. What are the three things I'm comparing here, beta? I'm comparing glass, water and air. I'm complaining here. Hi Veda, good morning beta. So here atmospheric composition, very good beta. So here we have understood many points. Now we are going to go for the next part. Ready beta? Let's go for the next part. So now we are going to write a very important question, because we are going to write examination for CBSE now. So for CBSE, certain important points we must remember beta. So that important point, when we are remembering, let's check this one out beta. Just little change I have done. Okay, so that the screen will be totally visible. Now look here beta, if somebody will be asking you, now you just check this one out, why a change in speed of light causes refraction. See, right now we learned the change in the speed is causes refraction, but now they're asking the same question, why? What is there in the question? Why this is happening? Correct now, we know this answer, but now what they are asking, why this is happening. Understood? So now what answer we are going to say? So we know that, I'm just moving so that you can see a beam of light. A beam of light is made up of tiny waves. What it is made up of? Tiny wave. So whatever questions are there, all questions answer back to back. Now we are going to get. Now the first point is beta, we are going to decode it and we are going to understand it one by one. What they are telling, a beam of light is made up of tiny waves. We know the light is having dual character. One, it is what? Wave character and particle character. So what is the particle is actually two things are there. We already know. Light will have show. What is the two dual nature of light? Wave and particle. Wave and particle. Understood? Wave and particle means it will be moving in a straight line. So here what they are telling, yes beta, here what they are telling that okay, the speed of a beam of light is made up of tiny waves. What it is made with? Tiny waves. Now second, when a beam of light consisting of light waves are traveling in a certain medium falls obliquely on the boundary of another medium, then one part of the light waves enters into the other medium first and its speed changes first. But the rest of the waves enter the other medium with a little bit later, and hence its speed changes a little later. So that means what beta? That waves are tiny waves, bunches of waves. Like you four people are there. Just like understand in a simple example as you and your friends. I'm telling as a simple example for you. Five of you went to your friend's house. Now friend is having one door now. All of you went together walking, making a group on road. But the moment you enter inside your friend's house, will you enter one by one, or will you all enter five together? Think, one by one you will enter, or you will all enter at a time? If door is big, wide, you can enter. Understood? But if the door is narrow, you will enter one by one. So till going to your friend's house, your speed was same now, because all five of you were walking together and talking. Understood? But the moment you went inside, you went inside the boundary, you went inside the gate of your friend's house. After that, what will happen? One by one, you will take entry. That means what? The first one will have a different speed, The second one will have a different speed. That is the main important catch. Very good, Ranjit. So that's the most important part, beta. One by one, Jotam. Absolutely. My children are giving correct answers. One by one. One by one. So that means what, beta? Some of them will enter first. After that, remaining of them will enter. So that is the real cause of change in speed. All light rays will not be able to enter the medium at one speed. Understood? All light rays will not be able to enter the medium at one speed. They will enter how, beta? One by one. They'll enter one by one. Absolutely correct, Veda. I hope children you are understanding this now. So that's what is written in the statement. Ashish, when a beam of light consisting of light waves are traveling in a certain medium fall obliquely. So beta, oblique projection is also one of the most important point. What is the meaning of oblique projection? Anyone can tell? Oblique projection. What is the meaning of oblique projection, children? Here oblique projection is also important to answer, because until and unless we will not understand what is oblique projection, we will not be able to answer many of the things. Can you say what is the meaning of oblique projection, bacha? Absolutely correct, Kavya. It is making certain angles. What is the meaning of oblique projection, beta? Making certain angles. Now we are going to decode it. We are going to understand what is oblique projection. So beta, this is a glass slab. Okay, so first we will draw normals. How we are going to draw normals? The normals will always be perpendicular to the surface. We draw normals, beta, and the normals will always be perpendicular to the surface. One by one. Absolutely correct, beta. So here, perpendicular to the surface. Now, the normal rays will make certain angle with incident ray. Understood? So this angle formation is called as oblique projection. The rays are not falling perpendicular. The rays are not falling perpendicular. If perpendicular means they are parallel to normal. I am going to explain this one. So if the light rays are falling like this, then there will be no oblique projection. There is no angle subtended. So there is no angle subtended at the case when the light ray will fall like this, perpendicular. The light ray will fall like this perpendicular, means no angle subtended between normal and this. So what will happen? Without bending, the light ray will enter and come out of the content. Understood? So that time bending will not be there. For bending, what we need? We need angle between incident ray and normal. Angle between which ray and which one, beta? Angle between incident ray and normal. What we are needing? Angle between incident ray and normal. Did you got the point very nicely, children? Did you got it very, very nicely? Come on, tell me. So beta, that's what. So angle, oblique projection is a very important thing. If angle subtended will not be there, means refraction will not be there. It will be exactly bending will not be there. Understood? So refractive index will not be able to be found. Now one question was there, and the question was asked by one student that, Auntie, can you tell me one thing? If I will see till the surface will make some angles with the normal, we will have refraction. Punchy. We will have what? Refraction. Understood? So till the surface will have some angles, it will be having what, beta? Refraction. Otherwise it will not have. So we need to understand. Ashish, can you tell me this point, please? This is a glass slab and this is normal, beta. That is a normal what I have drawn. A glass slab, yes, beta. Angle must be subtended. So there must be some oblique projection. Then only we can talk about refraction. So now the light rays are entering like this. Will it have any refraction on the glass slab? If the light ray, no, here I am covering it. I will not allow the light to enter. Okay. If it will enter from here, normal will come here. Understood? The light ray has to travel this distance. Understood or not? So what actually I am talking about is, if the light rays will go parallel with the surface, will it have any oblique projection with the normal? No. For oblique projection or making some angles with the normal, I repeat, for making some angles with the normal, it has to come and fall into this situation. This is there. So if little bit less also is there, sorry, little bit less also is there, means this much angle will be subtended. Understood? So it has to make 89 degree, 99 also possible, means little we can talk about, but 90 coming with the normal is not at all possible. I hope you might have understood this point, beta. Come on, say yes. Absolutely correct, Jotam. So we have a very important discussion here. We discussed about oblique projection, and we also discussed about the speed. Are all the light rays entering at one time? No, one by one. Some will enter first, after will enter, remaining will enter after that. And because of this, what is changing? Speed is changing. Because of which, what is changing? Speed is changing. That means we fall into another conclusion is yes, when the light is entering from one medium to another medium, speed is changing, because all the light rays are in package form. They will be exactly going one by one. Bhavya, this is a very important point we have discussed. I hope we got this point. Now here, so one part will speed will change first, and then the later part will change. The fact that speed of light wave on one side of the beam of light changes a little before the change in the wave of the other side causes a change in the direction of light. So beta, that's what the first one, yes, speed is changing. Absolutely correct, Ranjit. So that means this medium speed one, see, first one speed already changed, but second one which is not entering inside, its speed remains the same. Correct, na? The moment it will enter, its speed will also change. And because of one by one, one by one, one by one, going inside into the medium, the speed of the particles will keep on changing. And that's why bending is caused. And that's why refractive index will come. Very clear? Crystal clear. Come on, children. Give me a thumbs up if you have understood. Crystal clear. Yes, auntie, I've understood the concept very, very nicely. Come on, say, children. Did you understood it very clearly? That yes, auntie, this happened, that happened, and because of this, the entire things are changing. Very good, beta. Anu, Kavya understood. Maha understood. Quickly say, beta, you've understood. Yes, auntie, I've understood. This is the most important thing. So here, we must understand these things, then only we can proceed to the other side. So now, beta, this is the thing I was talking about from the beginning. Can you say, Veda understood, beta? Bless you, beta. So now listen. So that's what a glass slab is there. Now the picture will be totally clear now. Some part of the light rays are exactly entering, means the speed of them is changing first, and then the remaining part speed is changing. It is not changing at the same time. The speed is changing one by one, and because of this, bending has been occurred. I hope you might have understood. Jotam understood? Yes, beta. Crystal clear concept. And after that question answer session means it will go very, very clear. Okay. So till here we have understood this part. Now come on, go for this one. Now we are going to understand which side the speed is changing first. Right side or left side? Can we see? So if can we see beta which side is exactly changing first? That also we must know. Which side is changing first? That also we must know. Are we ready for it, beta? Are we ready for it? So right side, therefore, the direction of light changes or bending of light occur on entering the glass slab. So hence the speed of left side of the beam of light increases little before its right side. So where it is more, left side is more, little before the right side. So left side is more, little before the right side. Can we have another time checking, please? So can we see left side, right side, which is the shortest way to enter? Understood? So yes. So when we are seeing that, beta, so right side, therefore the direction of light changes or bending of light occur. Understood? So now that means what? Since the speed of left side of the beam of light increases little before the right side. So which side the speed is exactly increasing? Left. After that, right. Understood? So what we were inferring here is therefore the direction of light changes on coming out of the glass slab into air. So we are seeing left and right changes there, and because of this only the bending is exactly occurring. So this is one of the most important part. We have already discussed about the speed change. Okay, enter and exit both are important, beta. Enter and exit Both are important, means going from one medium to another medium, and then coming out from the medium also, then coming out from the medium, and that all answer is given here, beta. Can you check? So which side is entering first? A side. Understood? And so that it will slow down first. And which one is entering after that? B side. Then it will be slowing down. But which one will be going out first? This one will come out first and this one will come out later. And because of that, bending has occurred. Yes. So entire content is present in the PDF itself. So now I am going to go to the next section, beta. Optically rarer medium and optically denser. Children, we have discussed so much about rarer and denser medium. Na? Optical density and everything we have discussed to that much level. Now you can only read it and you will understand. First, what we need? Transparent substance, which we have already. Now we are going to decode it and say that, okay, yes, we have already understood. Now let's check this one out. So what is exactly given? Transparent substance. We know what we need is transparent substance. Bingo. Second part, known as medium, glass, air, certain plastics, water, kerosene, alcohol, etc. will consider as that medium. Already we know, we discussed. Now different media are said to have different optical density. Bingo, got you. Now we have all the content now connected with each other. Optical densities are the reason behind it. Understood? So different substances will have different optical density. It has to be transparent. What book taught before itself we are knowing. Correct now? So now that means what, beta? A medium in which the speed of light is more is known as optically rarer. This also we know. This also we know, na? Where optical density is less, it is rarer or denser? Optical density is less, is rarer. Optical density is less is considered as rarer. Optical density is more, denser. Understood? So optical density more is denser. Now we learn already. Air is rarer, rarer medium because its optical density is less. Optical density of air is less or optical density of glass is less? Optical density of glass is more or less? Come on, children, say optical density of glass. Optical density of glass is more because density is the particle. Now then again go to the same concept that entering inside the room. So glass is having more particles, air particles are in motion. It is not going to create disturbance. More vacuum will be there. Because of that, optical density of air is less. Optical density of air is less. Optical density of glass is more. So if optical density of glass is more, bacha, that time only we can say it is denser and air is rarer. Understood? Yes. So online children, Vishwa has given correct answer. Ranjit, they are giving continuously correct answers. So now beta, we will go for the next one. So here air is a medium in which the speed of light is less is known as optically denser. Already we know. Already we know, na? Speed less, optically denser. Bending will be more. Refractive index will be more. And it is a denser medium. Got it? Everything cut to cut we have first understood. Now glass is an optically denser medium than air and water. Why? Because the speed is least. What was the speed we have traced? 2 into 10 to the power 8 meter per second. Where speed was speed of light in water is 2 in 0.25. What is the speed of light in glass? Only 2 into 10 to the power 8, which is quite less. Which is quite less. How is the class, children? Can you tell me? Are you enjoying the class? Physics is that much boring? Is it interesting or boring? Come on, say. Is it interesting or boring? Are you understanding? Clearly say. Did you understood nicely? Yes, we have understood. Very good, beta. Very good. Bless you all. So today you all have participated. I'm seeing offline children are little bit sleepy, but online children now they are very active and they are answering very fast. The moment I'm finishing the question, they are answering. That's a very good point. Okay, you people little bit sleepy, but their Bhavya is active. I'm seeing Ashish is active. Understood. Interesting, Ranjit. Super beta. Like this only we will study. And recorded part will be there. Anytime you can see the video and learn one more time. Okay. So now beta, that means what? When a ray of light goes from a rarer medium to a denser medium, it will go towards normal or away from the normal? Towards the normal. Already we know. Good morning, Yadav. Good morning, beta. Name is Shivans Yadav. Okay. Good morning, beta. Good morning to you. Now listen. So, beta, when a ray of light goes from denser medium to rarer medium, come on, it's time to recapitulate. Away or towards? Away or towards? Away. So that means one time towards the normal, one time away from the normal. Understood? So now next part is when the light ray means refraction of light when it goes from rarer medium to denser medium. We can see it is exactly the usual path is which one, beta? The usual path must be this. Understood. But it is exactly doing what, beta? It is going near or away? It is going near the normal. Understood? It is going near the normal, towards the normal. Understood? Towards the normal. That's the most important point. Okay. So now we'll go for the next one, please. Now this is going away from the normal. Why? Because this medium is denser, this is glass slab and this is air. Understood? So when you are going from denser medium to rarer medium, the light will bend away from the normal. The light will bend away from the normal. So denser to rarer, rarer to denser, children understood? Jyotam, Vishwa. So is it exactly, it is supposed to move like this, but it is exactly going away from the normal. Understood? Yes, away from the normal, towards the normal and away from the normal. Absolutely bingo class today. I seriously enjoyed teaching you people because online children, they kept me alive. Super bitter. So the causes of light going air into glass and again to air, that's the most important thing. Here it is written so much. This PDF will be available to you. You can read, but I am going to explain in the most shortest way. Okay. So lateral displacement, what it is called as lateral displacement. We are going to talk about lateral displacement. So this is exactly considered as lateral displacement. Now I'm explaining whatever is present there, beta. I'm going to explain about lateral displacement. What is the meaning of lateral displacement? First, understand nicely. What is this one? This is the expected path of light. These dotted rays are the expected. The dotted line is the expected path. Good, Vishwa. So now, beta, listen, beta. Now listen. So this is the expected path of the light. Understood? So that means what is our normal expectation is if the light is going from one medium to another medium, it should go straight. This is our expectation. But is it meeting our demand? No. Understood? It is meeting our demand? No, beta. It will be exactly bending towards the normal. It is bending where, Vishwa? It is bending towards the normal. So when it will bend towards the normal, then there is refraction will be there. So an angle of incidence, when we will be talking about, check very nicely here, beta. Here this is I and there this is going to be, I am taking it as R1. So here I will be more than R1. Done? Now beta, this one and this one, same medium now. So we will take it as R1 or R2 we will consider and then it is E. So 100% here R1 will be less than E. Correct? Because this is same medium. So refraction angle, it is exactly getting same. So here R1, R1. So here I is exactly greater than R1. R1 is again less than E. So when you are going from one medium, again coming out from this to the same medium, that time angle of incidence will be equal to angle of emergence. Angle of incidence is equal to what, beta? Angle of emergence. I think it is not visible. Angle of incidence is equal to angle of emergence. So here we are writing I is exactly greater than R1. We will take it as R1. Understood? If we are same medium is there, we will take this one as R1 also and this one as R1. Considering, okay. So here R1 is less than E. So what is the, we are coming from one medium to another, then coming out to the same medium. So here what will become, beta? Angle I is equal to angle E. Angle of incidence is equal to bending towards the normal. Yes. Shivans, what happened, beta? Beta, see, original, the two things are happening there, beta. We must not deny the fact. Here, two things are happening. When the light is exactly coming inside, here refraction will also be one of the phenomenon. Understood? Every ray follows law of refraction in any medium. Understood? So it will have reflection, and then the minimum, the other rays which will be in the wave form, it will be having what, beta? It will have refraction. Means the light will enter into the medium. Some part of it will be reflected, some part of it will be refracted. And since the change in the speed will be there, the light ray will enter one by one, understood, in the waveform, and because of that, bending will occur. And this bending will either be towards the normal or it will be away from the normal. Understood? And beta, if it is towards the normal, what will happen? Angle of incidence will be greater than angle of refraction. And beta, when the light ray will come out from the medium, again what will happen? Yes, it will be exactly going away from the normal. That time refracted ray will be exactly considered as incidence. That time again incidence will be less and emergence will be more. But overall conclusion will come what, beta? Angle of incidence will come as angle of emergence when the same ray will come out in the same medium after going to another medium. Understood? But beta, here that is also cause of one more thing, that is called as lateral displacement. What is the meaning of lateral displacement? Here lateral displacement is exactly occurring because this is our expected travel. This is our expected travel, but the light ray is not traveling like this. It bent and it came out like this. Understood? So this is exactly the displacement. Understood? So this is considered as what, beta? This is called as lateral displacement. Actual path and expected path. That is totally apparent. So expected one and the actual one, there is a difference in that. The parallel distance, na beta, that is considered as lateral displacement. I hope everybody understood. So we are going to wind out till here only. Next class again, first little bit revision day after tomorrow morning, and then I will be explaining the entire section. How was the class today? Come on, say. Super, you understood everything, na? Lateral displacement also, na? The ray, actual ray, and the one which is after diverting coming. That this distance between that, displacement between them will be considered as lateral displacement. Lateral displacement. Okay, beta. Bye for now. हिंदी बेटा लिटिल बिट प्रॉब्लम हो जाता है हिंदी के लिए, मगर सीबीएसई में है ना बेटा, सो इसलिए, बट हिंदी में भी आई विल एक्सप्लेन समटाइम्स, आई ट्राई टू एक्सप्लेन इन हिंदी ऑल्सो. जो रियल रेज एक्सपेक्टेड थे और जो हमारा रे आ रहा है निकल के, उनके बीच का जो डिस्प्लेसमेंट होगा उसको हम लैटरल डिस्प्लेसमेंट कहते हैं बेटा. ओके, बाय फॉर नाउ, हैव अ नाइस डे टू एवरीवन. थैंक यू विश्वा.